Okay, so I'm just going to use the 11.3 part 2 special regular polygons to kind of go over this with you. If you're curious about it, it's good information. It might help you in pre-calc, but it's not necessary information, which is why it's not required. It's an extension. Okay, so within all of these, you have a 30, 60, 90 right triangle or a 45, 45 right triangle. So let's just remember the 30, 60, 90 right triangle, which would be x, 2x, and x root 3. Okay, so on this, it's an equilateral triangle because these are all regular polygons. If I drop this down here, and you find that angle at the center, again, or even right here, an equilateral triangle is a 60, 60, and 60, which makes these both 30, and then this would be your 60, and then your 90. If the hypotenuse is 10, then that means this short side here is 5. Okay, and then this is 5 radical 3. Okay, well, one way to do this problem is just to find the area of this one triangle and then multiply it by how many triangles there are. But really what we kind of were doing before is we were finding the area of this triangle here and then multiplying it times 3 because there were 3 of those. So to find the area of this, half the side length is the 5 radical 3. The apothem in this case is 5, and then there are 3 of those. So the half the side length times the apothem, and then it's a triangle, so it has 3 sides. So again, because this is an extension, we're going to keep this in simplest radical form. So 5 times 5 is 25. 25 times 3 is 75 radical 3. Okay, so let me just show you that again, and then there's a couple at the bottom if you want to try it on your own, and then of course the answers are on the back. Okay, so here, again, we'll drop this in. This is my 30, 60, and my 90. So across from my 30 is my short side. So 8 is the short side. This would be 16, which I don't need. I don't need that at all. But then this side here would be my radical 3 side, which would be 8 radical 3. Okay, so again, if I make this triangle, half of my side length would be my 8 radical 3. Multiply that by my apothem times my number of sides. Okay, so 8 times 8 is 64. And if I multiply 64 times 3, I get 192 radical 3. Okay, so that's your first special right triangle. I'm going to just slide over here to the hexagon, which also has special right triangles inside of it. Okay, so if you're given a side length, okay, so your 30, 60, 90s come into play because when you break this in half, so we're kind of twisting it the other way this time, the 30 degrees is up top here, 30, 60s over here, and the 90. So across from my short side is going to be my 7. So half of this is going to be 7, which makes the hypotenuse double that, and it makes the medium side 7 radical 3. So the apothem in this case is the radical 3 side instead of half the side length. So they kind of just flip-flop. So then half of my side length is 7 times my apothem, and then I'll multiply that times the number of sides. So 7 times 7 is 49. 49 times 6 is 294 radical 3. Here's where it gets interesting, because on this one, the apothem, which should be the radical 3 side, which we showed here, is 24. So if you remember correctly, it's been a long time since we've done that, but to get from the apothem down to the short side, you actually have to take and divide by radical 3. It's been a long time since we've had to do that. So this is 24 radical 3 over 3, which 24 divided by 3 is 8. So this is 8 radical 3 on the half of the side length. So we would take 8 radical 3 times 24 times 6, which is 1,152 radical 3. Okay, so that's just a quick tour of how special right triangles can come into play for special regular polygons for the 30, 60, 90s. There's one more, and it's the 45, 45, 90 that can show up inside of a square. And really this can look in two different ways. If you're given a whole number right here, we can make a 45, 45, 90 this way. So then this would be 14, this would be 14, and my side length would be 14 radical 2, which would make my other side length 14 radical 2. Okay, and I could go from there and multiply 14 radical 2 times 14 radical 2 and just get my area using basic old base times height. So 14 radical 2 times itself is 392. Okay, that's what I would do if you're given a whole number. If you're not given a whole number, then we'll go back to this half side length apothem stuff. Okay, so I'm going to drop in this triangle here, which this is also a 45, 45, 90. So this time my hypotenuse is 15 radical 2, which then brings this to be 15 and this to be 15. Which we could over here go half the side length is 15 times 15 times 4, which would work because there are 4 of those triangles, there are 4 sides. Or you could just see that if this is 15, then the whole thing is 30, and 30 times 30 is 900. Both of them would get you the answer, and which is why it's kind of silly to use the special regular polygon formula for this, because you can just do base times height. If you were doing it though, it would be 15 times 15 times 4, which is the same thing as the other way, 900. There you go.